Okay, so today I'll be going over quadratic functions and factoring. I'm going to combine 4.1 and 4.2, so that'll be graphing quadratics in vertex form, intercept form, and standard form. So some vocab words. The vertex is the highest or lowest point of a parabola, and the parabola is the shape of the function. The axis of symmetry is a line through the parabola so that each side is a mirror image. The minimum is the lowest point, and that's going to be the y-coordinate of the vertex if the parabola opens up. And the maximum is the highest point, and this is going to be the y-coordinate of the vertex if the parabola opens down. So just to show you what the shape kind of looks like, I'm going to plug in 5 points. So if I plug in -2 for x, y would be 4. If I plug in -1, y is 0. If I plug in 0, y is 0. If I plug in 1, y is 1. And if I plug in 2, y is 4. So on my graph, it'll look something like this. And you want to make this look U-shaped. And the axis of symmetry always goes through the vertex. So like if you fold your paper on that line, it'll be a mirror image. Okay, so next we have the 3 different forms and some different information. So I'll start with vertex form. The equation is f of x equals a times x minus h squared plus k. So what's given in this form is the vertex, and that's why it's called vertex form. And that's going to be hk. So it's going to be the opposite sign of h and the same sign as k. The axis of symmetry is the vertical line through the vertex. That'll be x equals h. And the vertex again is hk. So that's for vertex form. Then for intercept form, this is g of x equals x minus p times x minus q. So what's given are the x-intercepts, and this would be the points p0 and q0. So it's like if you set each of these equal to 0, what you get would be the intercepts. That's why it's the opposite signs. The axis of symmetry would be the middle of the two x-intercepts since it's a mirror image. So we would add them. Oops. P plus q and divide by 2. Then for the vertex, that would be our x-coordinate of the vertex. So that would be x plus... sorry, I keep writing x for some reason. Okay, p plus q over 2, and then g of p plus q over 2. So after you find that x value, you'll plug it back into your equation, and then that'll give you the y-coordinate of the vertex. And the last one is standard form. So standard form will look like ax squared plus bx plus c. And what's given is the y-intercept, which is going to be the point 0c, because if we plug in 0 into the equation, c is the only thing left, and that's going to be the y-intercept. The equation for the axis of symmetry is x equals -b over 2a. And for the vertex, that's going to be -b over 2a. So again, the axis of symmetry is going to match the x-coordinate of the vertex. And then we have to plug that in to find the y-coordinate. Okay, so next we're going to do some examples with graphing. I'm not going to go through the x-intercept on the ones that are not in intercept form because we're going to learn that later on in the chapter. Okay, so for the first one, this is vertex form. So the axis of symmetry is going to be the h value of the vertex, and we know the vertex is 1, 4. So the axis of symmetry is going to be x equals 1. For the y-intercept, that means we're going to plug in 0 in for x. So that'll be negative 2 times 0 minus 1 squared plus 4. So then that's going to be negative 2 plus 4, which means it's 2. So the y-intercept is going to be the point 0, 2. Okay, so to graph, I'm going to start at the vertex, which is at 1, 4, which is right here. And my my y-intercept is at 0, 2, which is right here. And since it's going to be a mirror image, that means I can reflect it and plot another point, so it would be right here. So you see how it's like one space away from the vertex, and at 2, we're going to do the same thing. So I'm going to go one space to the right and plot it at 2. And this negative means that's going to point, oops, sorry, I didn't really point to it. That negative there means it's going to open down. So that's another way to check that your graph is correct. So this is going to open down like this. And that means that we have a maximum. And the maximum is going to be at the point y equals 4, because that is our highest y value. And again, we're going to skip the x-intercept for now, and we'll come back to it later in the chapter. Okay, the next one is another one in vertex form. So that means we know the vertex right away, which is negative 2, negative 3. So the axis of symmetry is going to be x equals negative 2, since it's going to match the x coordinate of the vertex. The y-intercept is when we plug in 0 for x. So then we get y equals 4 minus 3, so y equals 1. So as a point, that would be the point 0, 1. On our graph, we're going to start at negative 2, negative 3. And the y-intercept is at 0, 1. So we can mirror that onto the other side. So since this one is 2 units to the right, and at 1, we're going to go 2 units to the left. And it'll also be at 1. And if it helps, the axis of symmetry is here. Sorry, I should have drawn that in for the first one. And that's also how you can reflect it. Okay, so it'll look something like this. So that means we have a minimum since it's opening up. And it's going to be at y equals negative 3, because all the y values are above that point. Okay, so let me just go back up here and draw in the axis of symmetry. Okay, the next one, this is intercept form. So that means we know the x-intercepts. So for this one, you can set up equations like this. Just set each part of the problem equal to 0. So we get x equals negative 1 and x equals 3. So our x-intercepts are going to be at negative 1, 0 and 3, 0. So then to find the axis of symmetry, we would add these two and divide it by 2. So that'll be negative 1 plus 3 divided by 2. It's 2 over 2, which is 1. So the axis of symmetry is going to be the line x equals 1, which is right here. So that tells us that our vertex is going to go through, or it's going to contain 1 as the x coordinate. So we will want to plug in, sorry, I have to write kind of small, so that's why I zoomed in. So we will want to plug in 1 into the original equation for x. So that'll be 1 plus 1 times 1 minus 3. That's 2 times negative 2. And we get y equals negative 4. So then that means for the vertex, that would be the point 1, negative 4. So 1, negative 4 is here. And then for the y-intercept, we're going to plug in 0 for x. So that'll be y equals 0 plus 1 times 0 minus 3. So that's going to be 1 times negative 3, so y equals negative 3. So 0, negative 3 is the y-intercept, and that is the point right here. And so we can mirror it and we'll get the point there. Oh, oops, sorry, hold on. And we also know the x-intercepts, which are at negative 1 and 3, so we can also plot those. It'll just make the graph a little more accurate. Okay, so it should look something like that. Okay, and since this is opening up, that means it has a minimum. And the minimum is at y equals negative 4. Okay, for the next one, this again is an intercept form. So that means we know the x-intercepts. So we can set just the stuff in the parentheses. So x plus 3 equal to 0 and x minus 7 equal to 0. So we get x equals negative 3 and x equals 7. So negative 3, 0 is one x-intercept and 7, 0 is the other. So then from here we can find the axis of symmetry. So that would be x equals negative 3 plus 7 over 2. So that's 4 over 2, which is 2. So for the vertex, we would plug in 2 for x and solve for y. So f of x is the same as y. So that's negative 4 times 2 plus 3 times 2 minus 7. Sorry. Okay, hold on. So then we'll get y equals negative 4 times 5 times negative 5. So we get y equals 100. So that's going to be the point 2, 100. Okay, and on my graph, it only goes up to 10, but I'm just going to change these to... I'm just going to make them go by tens. But only on the x-axis. Okay, and then I have to do the same thing on the bottom, so this would be negative 10. Okay, so let's start graphing a few of these things. We have the vertex, which is at 2, 100, which is right here. And, sorry, that was really thin. Okay, here. And the axis of symmetry is at x equals 2, which is right here. And then we also know the intercepts. So the x-intercept is at negative 3 and 7. And let's find the y-intercept. So we're going to plug in 0 in for x. So we get 0 plus 3 times 0 minus 7. So then that's y equals negative 4 times 3 times negative 7. And that's going to be 84. So 0, 84 is going to be on our graph. And even though we went by tens, we can kind of estimate it, so it'll be somewhere between 80 and 90. And we can plot another one also 2 units away to reflect it. And our graph will look something like this. So since it's opening down, that means we have a maximum. And the y value would be y equals 100, since that was our highest point. Okay, next one. This is in standard form. Oh, hold on. I wrote all the other ones in blue, so I'm gonna write this in blue. Standard. Okay, so in standard form, what we know right away is the y-intercept, and it's always going to be the c value. which is 4 in this case, because if we plug in 0, the 3 times 0 squared minus 6 times 0, that's just going to be 0. So the y-intercept is 0, 4. And for the axis of symmetry, that's going to be negative b over 2a. So here a is 3, b is negative 6, and c is 4. So that'll be x equals negative b, which is negative 6, over 2 times b, which is 3. So that's 6 over 6, which is 1. So x equals 1 is our axis of symmetry. Okay, and we also know y-intercept is at 0, 4. Okay, so next we have to find the vertex. So we're going to plug in 1 in for x. So y equals 3 times 1 squared minus 6 times 1 plus 4. So that's 3 minus 6 plus 4. So we get y equals 1. So our vertex is the point 1, 1, which is right here. So again, we can reflect that right there. And this will open up like this. Since this is not intercept form, we're going to skip the x-intercept for now and come back to it. And for this graph, it opens up, so that means we have a minimum. And it's going to be at y equals 1. Okay, for the last one, this again is in standard form. So we know the y-intercept is going to be the c value. So a equals negative 1, b equals negative 2, and c equals negative 1. So that's going to be 0, negative 1, which is right here. For the axis of symmetry, that's going to be negative b over 2a. So that's 2 over negative 2, which means the axis of symmetry is going to be at x equals negative 1. So now we have to plug that in. Oh, here, I'll graph it first. It'll be right here. Okay, so for the vertex, we're going to plug in negative 1 in for x. So we get negative 1 plus 2 minus 1, which means we get 0. Oops. So negative 1, 0 is our vertex, which is right here. So we can reflect that right there. And it's opening down. So this is going to have a maximum since it's opening down, and it's going to be at y equals 0. Okay, and the last part is writing quadratic functions in standard form. So that just means we want to multiply out the problems if it's in intercept or vertex form. So for this one, if you learned FOIL, you can do it that way, but I'm going to show you guys how to use the distributive method. So we're going to take the first term in the first part and multiply it to all of the second. So it's like we're distributing x to each part. And then we're going to take the second term, which is plus 4, and distribute that to all of the second part. So that'll be x squared plus 3x plus 4x plus 12. And then we have to combine like terms, which are these. So y equals x squared plus 7x plus 12. The other method is the box method. So for that, you would want to draw a box. And since this is 2 by 2, or we have 2 terms in each part, I need 4 squares. So I'm going to label the top x and plus 4, and the side x and plus 3. So we're going to multiply the two sides that make up the box. So in this top one, that would be x squared. This would be 4x, this would be 3x, and this would be 12. And then when you take everything out of the box, you would get this part here. So then you can combine like terms and get the final answer. Okay, so for this next one, it's a little bit different because it's in vertex form. So this would be f of x equals x plus 5 times x plus 5 minus 2. So x plus 5 squared means x plus 5 times x plus 5. So now you want to multiply that out, and you can use either the box method or the distributive method or FOIL if you learned it that way. I'm going to do the distributive method. Just make sure you keep it separate from the minus 2 because you want to do that part first. You want to always multiply first. So that would be x squared plus 5x plus 5x plus 25 and then minus 2. So we have two like terms we can combine. We can combine the 5x and we can combine the numbers. So that'll be x squared plus 10x plus 23. And that's how you rewrite it into standard form. Okay, hopefully this video wasn't too long. And I hope you understand how to graph and rewrite things into standard form. Bye!